Hello everyone. Very good afternoon. Can everybody see me and hear me clearly? Please tell me. Everybody can see me and hear me clearly. Please do share this session as much as possible. Namaste, namaste. Share this session, everybody. It is humbly required, humbly requested to kindly share this session as much as possible. Okay? Great. Share it everyone. तो अब dislikes का दौर आ चुका है and I'm very grateful to my haters as well who are caring enough and चलो कोई नहीं. Share it everybody. Good afternoon, very good afternoon. Just simply tell them that the class has started, session has started. This is the second lecture after today. लोग जलने लगे हैं, वो पहले से ही जलते हैं. अरे यार, तरक्की तो बहुत पहले से ही है. Good afternoon, good afternoon, good afternoon. A very good afternoon everybody. Chalo, share it everyone. So we'll start. Okay, so is there any doubt till what we studied yesterday? Is there any doubt till what we studied yesterday? Any doubt everyone? No? None? So shall we move forward then? Huh? Just one last time I would request, please share it and then we'll move forward. Please share it, then we'll move forward. Okay. Fantastic. So today what we are going to study is going to be yet another amazing concept for both radiation as well as convection, and then after we are going to start with main conduction part. Okay, so the mode is like this, that we are going to first give you the introduction of the modes of heat transfer. Yesterday we have seen conduction, today we are going to see convection and radiation, just the introductory part, and then after we are going to move forward with the other ones, right? I hope you understand. Anyways, let's just move forward. So now we have convection. Please pay attention, this is very important. So convection, right? Convection. Good afternoon, good afternoon, good afternoon. Convection, my dear students. So what is convection? How do we understand convection? And what does convection tell us? Let's move on to that. Good afternoon, good afternoon, good afternoon. So convection on and on is made up of two words, conduction and advection. Convection is not a word alone. It is not a word. It is made up of two words, conduction and advection. Conduction से कौन उठाया, advection से vection उठाया, convection बनाया. Okay? It means that convection without conduction is not possible. What do we infer from here? Convection without conduction is impossible. Am I right? Of course I am, I know that. So we cannot have convection without conduction. We cannot have convection without conduction. So for convection to occur, there must be, conduction, and advection is something there. Now what is advection? Let me tell you. Advection. The bulk motion of fluid particles over a surface. Now this bulk motion is very much mandatory, right? So on and on, what should I say? in convection mode of heat transfer, in the convection mode of heat transfer, what happens? The heat transfer occurs due to motion of fluid particles, motion of fluid, which is the medium particles. Have I not told you this yesterday? Have I not told you this yesterday? Right? So this is simply the definition. Okay. Now what is the mechanism? Real mechanism. Let us go with the mechanism so that you will be easily understanding this. Alright? Okay. Let's suppose this is a surface. Let us suppose that this is a surface whose temperature is Ts. The fluid is T infinity. Now I'll tell you what is T infinity. This here constitutes free stream of fluid. Okay, free stream of fluid is flowing, and this is your hot surface. Let us say, what is it? It is nothing but hot surface. All right, free stream of fluid, hot surface. Problem clear? What is T infinity? T infinity is the temperature, free stream temperature of fluid in free stream. This you might have studied in your boundary layer, right? There we used to have U infinity, free stream velocity, and what is Ts? Hot surface temperature. There is nothing but the hot surface temperature. Am I clear, everybody? Am I clear, everybody? So that is hot surface temperature. Okay. Now we have this free stream flowing over this hot surface. Now what will happen? Whenever the fluid is flowing over a surface, its one layer gets stuck on this surface. Say yes or no. One of its layers gets stuck on this surface. Yes or no? What do we call this layer as? No slip layer. What do we call it as? No slip layer. Do you know why does it form? The formation of no slip layer. Okay. So the fluid is coming from this side. The fluid particles will get, attached in this. And suddenly whenever they are coming with some momentum. They have some velocity, they have the mass, hence they have some momentum. So what happens when they are coming and they are attacking here, they are striking on the surface, some of the momentum is lost. Yes or no? It's very simple. Some of the momentum is lost. So there is a sudden loss in momentum. And also when the momentum is lost, the fluid particles will readily sit here. So the fluid particles are sitting here. Momentum is already lost. Now, in order for them to move, they must have some velocity, but they have lost it. So hence they cannot move. So because of this surface roughness and there is one more factor, sudden losses of momentum. Because of surface roughness and sudden losses in momentum, this is not going to, move. This layer is going to be stagnant here. This is known as no slip layer. If the plate is not moving, the layer will not move. If the plate is moving, the layer will move along with the plate with zero relative velocity. Okay, that's why no slip layer. There is no relative velocity between this layer and the plate. Okay, everyone. Any doubt in this? Tunneling जैसी phenomenon यहाँ नहीं होगा. नहीं. simply stagnant. Utna zyada momentum nahi, you don't have that much of momentum. Anyways, you understood everyone? You understood everyone? So this layer is formed. Clear hai? Clear everybody? Why this layer is formed? The reason, there are two. What are those? Number one, the very first reason. The very first reason is surface roughness. Number two, sudden losses of momentum. Okay? Please take a screenshot, then we'll move forward. Take a screenshot, please, then we'll move forward. Please take a screenshot, and then we'll move forward. Okay? Fantastic. I think you might have. Now, that means, please pay attention what is happening now. So we have this free stream, am I right? Okay. No slip layer is there. I'll say in short NSL, no slip layer. Not National Soccer League, right? No slip layer it is. Right? So what happens? The fluid particles are coming as a batch. They're coming together. Okay, these are the fluid particles. So let us say this batch has come. This batch has come here. Now, these fluid particles have a property known as a specific heat. So because of that property, they will pick up some heat. They will pick up some heat. And after picking up some heat, they will move forward. Next, another batch will come. That batch will do the same. So in this way, the batches of fluid are coming in, fluid particles are coming in, they are picking up the heat and then moving forward. Yes or no? Is it clear, everybody? They are picking up the heat and then they are moving forward. This is readily happening over this, at this position, right? This is continuously happening in this position. Understood, everybody? Say yes or no. So this batch is coming, it is picking up some heat. Now how it is picking up heat? Let me give you more detail. How is it picking up heat? See, the heat first goes by conduction. This is showing you conduction from the plate to the no slip layer, and after which it is taken up by convection, advection. Now what is advection? Bulk motion of the fluid particles. Understood, everybody? This is the bulk motion of the fluid particles. It is very simple. It is very simple. Yes or no? Eagerly waiting in live class. I am there in live class. Acha, okay. In live class. Okay. Got it. So, yeah. Understood, everybody? Understood now what is happening? The mechanism, right? You guys remember I told you yesterday? Suppose this is the beaker or container of water. And in this container of water, you have put it over a, flame, or what do you call it? Is known as simply or burner and all. And there you have water. So the lowest layer will again be the no slip layer or whatever. It will be stagnant at this position. Now heat will get transferred from here to there by conduction, and slowly the nearby particles will get into contact and they will get heated up, temperature increases, density decreases, so they will rise up, and in their position, to take their position, the heavier particles will come down. So there is a convection current setup. Understood? Understood? So what is happening now? What is happening now? By conduction, this hot surface is giving heat to the no slip layer, and the other fluid particles are coming in, and since they have a heat storage capacity, they are able to store the heat. They will take up some heat, they will pick up some heat, and because they are already in motion, they will move away. Understood everybody? Feeling clear हुआ या नहीं? Yes or no? That is why I told you that convection without conduction is impossible. If you remove this conduction, you simply do advection. There is no effect you are obtaining. Are you getting my point? At least heat should go there, no? At least heat should go there, then it will be picked up and sent away. Yes or no? Got it? And because the fluid particles are continuously in motion, therefore every time the bulk, कौन सा bulk? Of fluid particles, right? This bulk, this chunk of fluid particles picks up some heat from the surface, we should say from the surface, or NSL also, from the surface, and moves forward. Okay? And then it moves forward. It keeps on happening. Repeats continuously. This repeats continuously. So this keeps on happening continuously. On a continuous basis it is happening. Simple. That, my dear students, is your convection. मजा आया नहीं ये बताओ? Understood? Yes or no? Now let me give you one more beautiful example. Right? You might have seen, you might have observed that the car engines are water cooled. Yes or no? Because water, whenever is flowing, is able to take away more heat. Why? Because while advection, I told you one thing, that the fluid particles have a property known as specific heat, which I have already taught you in thermodynamics, if you remember. So in thermodynamics, what did I teach you? I taught you that specific heat is a property which describes the heat storage capacity of a system. So for example, for water it is 4.18 kilojoule per kg Kelvin. Means for a unit Kelvin change of temperature and 1 kg of water, 4.18 kilojoule heat it can store. Whereas for water it has 1.005 for air, sorry. So air cooled engines are not that much effective. For example, air cooling is not effective in large engines. Why? Because more heat it cannot take away. whereas more heat can be taken away by water, since it has huge capacity. Right? Understood? Maza aaya nahi? Advection alone cannot explain. See, fluid is moving. Okay, fluid will move, no problem. But it has heat storage capacity. Yes or no? Because it has heat storage capacity, which is explained by its value of specific heat. So based on that, we are describing that, okay, fine, cooling has to be there. Got it? Got it? Everybody, please tell me. Everybody, please tell me. Understood or not? The concept is clear or not? So this, my dear students, is your convection. Conduction plus advection. Now, if you remove anything, for example, there is no transfer. I mean, let's say over here you have a fan which is blowing the air. Suppose you have a fan over here which is blowing the air. Now this fan is an external agency which is facilitating the movement of air particles. Yes or no? So the fan is an external agency which is facilitating the motion of fluid particles. Yes or no? If I remove this, there will be no external flow of the air particles, and if there is no flow, there is no advection, so it will be only conduction in a stationary medium. Yes or no? Natural convection will take place. That's a separate mechanism, but that is not that much effective. It is not that much effective in as in the case of forced convection. Got it, everybody? Got it, everybody? So this is your convection. Okay? Understood? Understood? Got it, everyone? No doubt in this? Please take a screenshot. Yeah, please take a screenshot. Screenshot taken? Everyone? Great. Okay, so yeah, this is pretty much about it. When we are going to study the laws governing heat transfer just after this, you'll enjoy it more. Okay? Let's have a look. Let's have a look. Now let's talk about radiation as well. A little bit about radiation. What is the mechanism? How do we explain radiation? Right. So first things first, whenever good afternoon, bear ji. Do I look like a bear? Huh? Do I look like a bear? Anyways, so radiation. Whenever we are talking about radiation, radiation in general is a phenomenon, and in general is a phenomenon, right? But in heat transfer, we are concerned about thermal radiation. Okay, we are much more concerned about thermal radiation, not radiation as a whole. We are concerned about thermal radiation. So there is a specific domain in radiation on which our attention will be focused, and that specific domain we'll talk when we are going to explore radiation in a much detail. Okay. Let's see. So what about it? Sir, what do we mean by radiation? How do you say radiation is something or blah blah blah? See, it is a mode of energy transfer. It is a mode of energy transfer. I'm just simply talking about energy right now. Okay, it can be any energy. Energy transfer in the absence of any medium. Okay, any medium. It's a general perspective, general observation that okay, without even medium, without even the presence of a medium, radiation can happen. But we are concerned with a generalized aspect of it. Okay, so we'll talk about it. Sad to know, radiation में सिर्फ लिमिटेड ही पढ़ना रहता है. कोई बात नहीं, सब टच करा देंगे आपको. Don't worry. So mode of energy transfer in the absence of any media, right? Now, but let me explain it to you. Let me explain something to you. Okay, when is heat given to bucket of water with the help of rod? What is it called? It is free convection. That is free convection. See, मैं आप बोले थे कि air in between poor, but there must be radiation because of large temperature. Why not liquid cool? क्या transmissivity 0 होता है? सुनो. See, I have two questions. Let me answer those one by one. Okay. Sumit's question was asked first, so I'll answer Sumit's question, and then Narendra, your question I'll answer. Okay. Wait. So about Sumit's question. In winters, what do we have? We have a bucket. And in that bucket, what do? We insert an electric rod. Like this. Huh? And it is filled with water. So now what happens? Let's say Yeah, so now what happens? You might have seen this happening in front of your eyes. Okay, let me tell you. What happens is the fluid particles around this becomes hot. Yes or no? They will become hot. And definitely when they become hot, their temperature increases, their density decreases. Right? Because of this decrease in density, they will move up, they will be acted by a buoyancy force, right? They will move up. And when they have moved up, the heavier particles will come down to take their position. Yes or no? Okay. Density decreases, hot particles move up. Right? Cold particles, and these cold particles are heavy. Remember this, right? Move down to replace them. Yes or no? Huh? And then again they are heated up. Then again they move up. And then again the cold will come down. So a convection current is set up. A convection current. What does this mean? What is a convection current? This is a convection current. This motion of hot particles up and cold particles down, that is a convection current, right? And this convection current is happening due to buoyancy effects. Am I right? Is it happening due to buoyancy effects? Yes, it is. Yes or no? It is happening due to buoyancy effects or density differences. Am I clear? Density differences. Hence the causes are natural, not due to an external agency. Okay? Right? So the convection can be subdivided into two parts. Am I right? The convection can be subdivided into two parts. What are those parts? Forced convection and free or natural convection. So what's a forced convection? In the presence of an external agency like fan and all, external fluid flow is required. This absence of such, in the absence of such, and due to density differences, buoyancy effects. Now understood, Sumit? Understood, Sumit, that this is known as free convection. Motion is there, right? That is your free convection. That, my dear, is your free convection. Okay? Conduction kahan hai? Conduction yahan hai. Of course, they will come to this, hot surface. They will take up heat. Heat is conducted. Okay? Then they become hot, and then again this phenomenon happens. Got it now? So conduction is happening like this. Clear, everyone? Clear, everyone? Okay. So now about the thermos flask. Let me tell you. You have this thermos flask. This thermos flask is shiny on the outside. You might have seen, forced कब होता? Forced तब होता जब मैं इधर एक fan लगा देता या stirrer लगा देता, and that fan would have stirred it and propelled this fluid upward. So it would have facilitated the fluid flow. Yes or no? So whenever we are facilitating the fluid flow by some external agency, that, my dear students, is known as forced, and free is happening on its own. Simple. Got it? Javed Akhtar Saab and everybody else. Now let me tell you one more thing. Yes, about radiation, right? So in radiation you will study, and since you might have studied it a little bit, let me tell you, rho plus alpha plus tau. Narendra, you might have heard about it. Just for your, I have not yet introduced it, I'll explain it, I'll derive it further, but for your sake of explanation, I am giving it. Okay, so transmission is not there. Of course, you have this solid part, you don't have transmission on the outer surface. On the outer surface itself, which is shiny, made of puff aluminium and aluminium alloys, this is 0. Okay, now rho equals 1 minus alpha. Yes or no? Or I should say alpha equals 1 minus rho. And from Kirchhoff's law, you know that alpha equals to emissivity. So 1 minus rho. Since the reflectivity or reflection characteristic of aluminium is very high, so majority is reflected, so the emission is very less, you should say. Okay, or even if in terms of absorption, if maximum is reflected, absorption will be minimum. Hence, even due to radiation, even because of radiation, it doesn't matter, right? It doesn't matter. Even if radiation is there, it will neither take up heat due to that, and nor it will release heat. So that's the case. I hope you understand this. Okay, I hope you understand this. So that's why we make the outer surface as reflective one. That's why we make, on purpose, make this outer surface as reflective one. Have you got this concept? And also you might have observed, you have this aluminium foil, right? So that aluminium foil, that shiny surface is outside. Why? So as to prevent the losses due to radiation. Got it now? Got it now? Shall we move forward? You want to take the screenshot? Of course, we will study radiation further. But you want to take the screenshot? Please take it. Then we'll move forward. Please take the screenshot. Okay? Fantastic. Yeah. Now, my dear students, let's talk about radiation. So see, suppose, let's come back to radiation. This is transfer of energy in the form of electromagnetic waves, and these are transverse waves. What's the meaning of that? They don't require any medium, right? In the form of transverse waves, right? Why is it happening? अगर cold water में hot water डालेंगे तो वहाँ कौन सा mode of heat transfer होगा? See, whenever you are simply putting it, internal diffusion is taking place, internal temperature gradient is there, it will be conduction plus free convection. There also conduction and free convection. But if you are stirring it, it becomes forced. Simple. Hai. Got it now? Satya Prakash? Right. So the transfer of energy in the form of electromagnetic waves. Why these electromagnetic waves are formed? These formation of electromagnetic waves can be described on the basis of energy band theory, 12th standard. You remember energy band theory? You remember 12th standard? Suppose that there is a particle that receives heat. When this particle is receiving heat, what will happen? By taking up this heat, it will become excited. Yes or no? When it becomes excited, it will change its band. Means, what am I telling you? That it will change its position. How? For some energy state, it has some equilibrium state. Now, if it has more energy, its equilibrium state has to change. So, it changes its equilibrium state. So, when it has changed its equilibrium state, eventually it will come down to its stable state only. मतलब आपने तो उसको चढ़ा के, you have simply given it some energy, and by taking up that energy, it has become excited. But after some time, it will have to lose its energy. That's the normal tendency, because it cannot remain at the excited state always. Are you always happy? Are you always like, wow, tod phod macha denge? Are you like this? No. So your stable state is something else, right? So you eventually come down to your stable state. How do you do that? By losing some energy. Yes or no? And that energy is lost in the form of electromagnetic waves. Yes or no? And that, my dear students, is known as radiation. Got it? That, my dear students, is known as radiation. Now, that excited state can be achieved by, excitation of electrons, excitation of positive particles, alpha particles, which you call, right? Or simply excitation of the atoms only. So there are very different excitations happening, and resultant of that, we have different spectrum of radiation. Now understood why radiation? We have different levels of radiation. Why do we have cosmic rays? Why do we have gamma rays? Why do we have X-rays? Why do we have this UV radiation, visible radiation? Yes or no? So it all depends on the excitation. How much excitation energy you have given. It goes to a certain level, and then when it returns back, it will release the energy. It releases the energy in the form of electromagnetic waves. Some you can see, some you can't see. Understood? Everybody? Understood, everybody? Please tell me. Clear? Little bit on cosmic rays. We'll discuss cosmic rays, Baba. Wait. I'm just giving you the introduction. Okay? Please see. So we have different spectrum of radiation. We have different spectrums of radiation. Let me tell you one more thing. There is something known as Prevost theory. I'll explain it in the radiation. I'm just giving you the, introduction to radiation. I've just given you the introduction to convection. I've just given you the introduction to conduction. The domain is very large. So when we are going to explore the domain one by one, I'm going to tell you each and everything about it. Okay? Right now, let's talk about the spectrums of radiation. And these spectrums, they include, see, they are like this. To us, the reference should be VIBGYOR. Yes or no? Or visible range. VIBGYOR. Right? Violet, indigo, blue, green, yellow, orange, red. This is visible range, and this lies between 0.7 to 0.4. Microns I'm talking about. These are in microns. And this is wavelength. Okay? Wavelength in microns. 10 ki power 2. Till here, you have infrared. This is infrared. Okay? Then up to 10 to the power 4 or 10 to the power 5 to be exact, you have microwave radiation. This is the domain for radio waves. Okay? Till here, 10 to the power minus 2, you have ultraviolet. Ultra UV, जिसे बोलते हैं ना, ultraviolet. Then 10 to the power minus 5, you have UV, then you have, what is this known as? Yeah, X-rays. And then you have, furthermore, 10 to the power minus 7, minus 8, something like that. It's an overlapping range somewhere. And then you have gamma rays. Hulk jisse bana na? Gamma rays. And there you have cosmic rays. Cosmic rays are the most dangerous forms, right? You might have seen that movie Fantastic Four. They go into the space and they are hit by a bundle of cosmic rays, and someone becomes a stone man, someone becomes a fireman, someone becomes an invisible girl, and another one becomes stretchable man. But don't try this. If you go there and if you try and expose yourselves directly to cosmic rays, they'll simply kill you right away. Okay. Are you going to make it that large? Who took 72 classes? Who took 72 classes here? What is the radiation in phone, mobile tower? It is also in EM. See, EM waves, everything is EM wave. Everything is electromagnetic. But they are radio. They fall under the radio waves range. Got it? They fall under radio waves range. Clear hai? Yes or no? Okay, Mr. India. I don't know who that is. Who took 72 classes, I'm asking. Who took 72 classes? मैं तो वही पूछ रहा हूँ ना. Who took 72 classes? Can't name, but please make it short and sweet. I don't know who took 72 classes and of what duration they took. And I'm not even concerned. If you follow my lectures, I promise you that much, that yours questions of heat transfer will be completely taken care of. Okay? Don't worry. X-rays, gamma rays, cosmic rays, ultraviolet, Vibgyor. This is our visible range. And from here you can infer that wavelength increases, and over here frequency, or I should say nu increases to this side, because nu equals to C by lambda. Yes or no? Nu is frequency. It is in hertz. Okay, and E equals to h nu. This also you know. H is Planck's constant. So energy is directly proportional to the frequency, right? Energy is yeah, don't be worried. Don't be worried. मैंने लिया. क्या लिया यार? समझ नहीं पा रहा हूँ. Don't worry. Don't worry. At the end, I'll simply say that don't worry. I will not take extra time. Okay? Short and sweet were thermodynamics. In the same way, heat transfer will be short and sweet as well. Okay? I am fully committed in completion of the course on time. Okay? If I am teaching for 72 or odd 100 hours, heat transfer only, I don't want you guys to do a PhD on that. Understand this. इंडस्ट्रियल ख़त्म हो गए के बाद क्या स्टार्ट होगा, प्रोडक्शन के बाद क्या होगा, कुछ इन्फॉर्मेशन नहीं मिल रहा है क्या, फ्री क्रैश कोर्स. अबे भाग, कुछ बंद नहीं हुआ है, कुछ बंद नहीं हुआ है. नथिंग हैज़ बिन क्लोज्ड एंड व्हेन इट विल कंप्लीट HT about in 27 odd classes, 27 to 28 odd classes. Okay, information will be made available. Information will be made available. Okay, please now can we study? Please can we now study? Huh? This, my dear students, frequency, they are inversely related. Hence, wavelength increases, frequency decreases, and frequency increases, wavelength decreases. E equals to h nu, Planck's constant. Means cosmic rays have highest energy and they have the least energy. Yes or no? Second most thing, yes, you can extract information from photon. Yes. there's a technology which the scientists are working upon, in which these magnetic field magnetic discs are trying to be replaced by glass discs. They occupy least space, and they can store 10 times more the information. So that's a photon based technology. Okay, understood. Now please pay attention, scientist. Please take the screenshot. Please take the screenshot. This is the simple basic part, and we are going to study each and everything in detail. Please take the screenshot. Okay. For us, let me tell you this. 10 to the power minus 1. Only this part is important. Only this part we'll study, because this part falls under thermal radiation. Why only this part? Why not the other ones? And sir, please, माइक्रोवेव में तो खाना गर्म करते, वी hot the food, we make the food as hot by putting it in the microwave oven. So why are we excluding this microwaves from thermal radiation? That's a question to ponder upon. And why are we excluding this region as a whole from thermal radiation? I mean, from the perspective, from the real definition of thermal, we can sense that thermal radiation leads to heat transfer. Then why are we leaving this? Because microwaves in microwave oven, they're used to heat up the food. Why are we leaving this? Why are we leaving that? These are the questions which we'll answer when we are going to start radiation. It's going to be very interesting. Okay? Okay? Chalo. Now we have something known as laws governing the heat transfer. What are the laws governing heat transfer? So first things first, let me talk about the laws governing heat transfer. About laws governing heat transfer. Don't you think that heat transfer, first of all, will always follow the second law of thermodynamics? Yes or no? The transfer of heat will always be in accordance with the second law of thermodynamics. Is it clear? The heat transfer will never violate second law of thermodynamics, be it conduction, be it convection, be it radiation. Yes or no? Let me tell you. So this is very important point, that heat transfer always occurs in accordance with the second law of thermodynamics. Okay, fine. That means naturally heat is transferred from high temperature to low temperature. You will confuse, so let me write it full. High temperature to low temperature on its own. This we have studied, yes or no? Simply this we have studied. If you want to transfer heat from low to high, you need to give some external work input. Yes or no? This you have studied. Clausius statement, right? Now let me give you one perspective. Conduction, it is okay. Convection also it is okay, we'll see. But radiation, you will say that, sir, in radiation, from low temperature also heat is being transferred, right? And it goes to other parts. So it means that is it violating second law? radiation violates second law? It's a big statement to make, but this is wrong. This is where 99% of the people will be wrong. And if you ask anybody, they'll be confused. They'll be super confused. People always say that there is one mode in which from low temperature heat is going to high temperature. No. That is not heat, that is simply radiation, energy. Net heat transfer is always seen. It is always the net heat transfer. Heat is a transaction. It is not a bulk of energy. It is a transaction. So if the high temperature is releasing some energy, the low temperature is releasing some energy as well, the difference between them will always be positive, high minus low. That means that is the heat transfer. Otherwise it is simply radiation, energy. Since it is radiating the energy, it will radiate the energy, no problem. It has the characteristic, but it is not heat transfer. It is never heat transfer, because heat transfer is a transaction, right? And since the low temperature body is also receiving heat from the high temperature, also receiving energy by radiation from high temperature source. So the difference, on and on you will see the difference, and that difference is your heat transfer. This is a very beautiful concept and very confusing as well at the same time, because 99% people are confused. That is not heat. Heat is transfer. Heat is a transaction. It's like a currency. Yes or no? Understood? Understood? Because heat is a transaction. You consider it as a transaction. It is transfer. Whenever we talk about heat, it's a boundary phenomenon. It's transaction. It is transfer. You cannot store heat. You cannot store work. Those are all boundary phenomenons. Yes or no? Got the concept, everyone? Don't ever be confused that, sir, in radiation, the energy is going from low temperature to high temperature because it is radiating. So hence, eventually it will fall to the other place. It will fall to the other high temperature body as well. So sir, is it violating the second law of thermodynamics? No, it is not. It is not. It is not at all. Because it is simply radiating the energy by the virtue of energy band theory, which I have told you earlier, that somehow it has been excited. And in that excitement, in that excitation, it has gone to a higher energy band. Now when it wants to come back, it will release the energy in the form of electromagnetic waves. And when it has released the energy in the form of electromagnetic waves, that is simply the release of energy. But whenever we are talking about heat transfer, that is a transaction. That is a difference from high temperature to low temperature. So hence the second law is never violated. Second law of thermodynamics always holds strong. Got it? Got it? Exactly. And net heat is transferred. See, heat, whenever we talk about heat, heat is always transferred. It cannot be stored. It's something which is, it's a kind of a currency. You can store gold, but you cannot, circulate gold. Okay, यार चाय पत्ती देना, ये ले 10 ग्राम गोल्ड ले लो, लुट जाओगे. You understanding my point? You can store gold. In the same way you can store internal energy, but you can never ever store heat. Okay? That's the key. That's the entire concept which I have taught you in thermodynamics. Is it clear, everybody? So let's simply start with radiation. Laws governing. There are separate laws governing for radiation, conduction, convection. Apart from second law, second law is always valid. Second law is always followed. We will never deny second law. But there are separate laws as well. So let's start with that of radiation. Number 1. Stefan Boltzmann law of radiation. See, there were two people, Stefan and Boltzmann. They are two different people. They were from the same country, Austria, same city, Vienna, and they didn't know about each other. They were separately developing the same formula. Okay, Boltzmann gave it theoretically, Stephan proved it, and they proved it with the help of thermodynamic relations. Okay, you don't need to go into the proof, that's tedious and not at all required. Simply it says that EB, or we should say simply EB, equals to sigma T1 की power 4 EB1. Now, what does it say? What is the meaning? How do we explain this? EB is the emissive power of a black body. See, now let me explain you the concept of black body. Let me explain you the concept of black body. See, if for example I draw this line and I tell you that, okay, bacha, do one thing, just go and tell me the length of this diagram, the length of this line. You will be shocked. You will be shocked. Sir, are you nuts? We don't have laser in our eyes. We cannot do that. I'll say you can. You'll say how? Just go to the market, buy a scale. With the help of that scale, put it over there and measure the line. Yes or no? So hence you require a reference for that. Yes or no? You require a reference for all the measurement purposes. Are you getting my point? You require reference for the measurement purposes. That is very important. Now, so black body acts as a reference. Acts as a reference, my dear students. This acts as a reference. What is a black body? The black body acts as a reference. Always remember this. Acts as a reference to study radiation. See, radiation in a whole is a very complicated phenomenon, and we still don't have the fully developed theory of radiation. I mean, radiation is very difficult to understand. So whenever something is difficult to understand, what do? We take a reference. Yes or no? So this, my dear students, black body is a reference over there. Ideal case. Okay, it's a perfect emitter, absorber. We'll see when we'll study the radiation. Meanwhile, you simply take it like this, that it is the ideal gas for radiation. Ideal gas is nothing. It's simply an approximation. In the same way, there is no body which is perfect black body, but you can idealize it. You can take it as a reference. Okay, got it? Got it, everyone? So hence, emissive power of a black body. Emissive power of a black body. What is sigma? That is Stephan Boltzmann constant. Stephan Boltzmann constant. Its value is very interesting. 5.67 10 की power a minus 8. 5678. ऐसे याद कर लो. Now, this is watt per meter square Kelvin की power 4. Because this EB1 is in watts per meter square. This is emissive power. Flux, in a sense. This is flux. Suppose there is total area, surface area, and per unit surface area from each and every point from the surface, how much energy is released? That is flux. What is flux? From each and every point on the surface, how much energy is being released or how much radiation is taking place? That is your flux. Radiation flux. Got it? Understood, everyone? Got it, everyone? Don't worry about it. Okay. Now, T is always kept in Kelvin. Never forget this. And never in degrees Celsius. You'll never keep it in degree Celsius. You will always keep it in Kelvin. Got it? You will always keep it in Kelvin. You will always keep it in Kelvin. Why? Because if you keep it in degree Celsius, see, for example, 2 to the power 4, 2 degrees Celsius you have. 2 to the power 4, how much is it? 2 to the power 4, 16. But if you convert it in Kelvin, it becomes 275. To the power 4 is not at all 16. That's a different value altogether. Got it? Understood? So that, my dear students, is the governing law. Although there are different laws as well. Kirchhoff's law is there, we'll study. We'll also study Planck's law, which is very important. With the help of Planck law, that's a universal law. You can also derive this law. You'll have Lambert's cosine law. You'll have Wien's displacement law. But this, for the starters, is one of the laws which is governing the radiation. Okay? Is it clear, everyone? Is it clear, everyone? Concept is clear? Please tell me. Please tell me. Is the concept clear? So this is the law which is the governing law. Please take a screenshot. Please take a screenshot, then we'll move forward. Then we'll move forward. Okay? Anybody wants to ask any doubt regarding this? No? Now, number 2. Newton's law of cooling. Newton's law of cooling. There's so much of ambiguity here. I'll explain each and every case. Newton's law of cooling for convection. Convection. Okay? Newton's law of cooling for convection. Now what is Newton's law of cooling? How do we explain this? See, Q convection, heat transfer due to convection, is proportional to delta T. Higher the temperature difference, more shall be convection. Yes or no? If you want more convection to take place, you should have a greater temperature difference. It is simple. Right? Whichever heat transfer, see, heat transfer is occurring due to temperature difference. So if you have higher value of temperature difference, on this channel, it will be in English only. There's a separate channel, it will be in Hindi, but I would urge you guys to understand here only. I'm using simple English. I'm not using, the English of the level of Harvard or Shashi Tharoor level of English. Got it? Anyways, so this is proportional to delta T. Also, Q convection is proportional to AS. What is AS? Surface area. Arey baba, surface area. Okay, let me give you the example. Let me give you the example. You guys eat dal. Dal. Pulses. Lentils. That you call in English lentils. So when you have this dal in a katora or in a bowl, so you take that dal in the katora, in the bowl, that is hot. But your mother, everybody's mother, is a born genius. She has not studied, heat transfer, but she knows every principle by experience. That's why you should respect your elders. So she says that, beta, don't worry. You do something. You'll ask, what? What should I do? She always tells you that spread it on the entire surface of the chawal. Spread it on the entire surface of the rice. So that the surface area increases and the rate of heat transfer is more and more heat can be taken away. Got the concept, yes or no? Got the concept, yes or no? Also, it's a different phenomenon, but you can, analogize this. How? Take an analogy. If you have this, what is this known as? a cloth, you have washed it, and you have washed it and simply क्या बोलते हैं उसे, निचोड़ दिया पूरा. You have taken that water out, and if you keep it, it won't dry up as easily. But if you want to dry it up fast, simply take it out and spread it, and then put it in the sun. Got it? Got it, everybody? Got it, everybody? So this is what is happening when you are increasing the surface area. Due to the increase in surface area, due to the increase in surface area, due to the increase in surface area, there is an increase in heat transfer rate, which is convection. Okay? Which is convection. Got it, everybody? Got it, everybody? And that is why in winters, if you don't have a blanket, you sleep like this. You sleep like this. Anna? Sleep like this. You make your body narrow. Why? Because if you're making your body narrow, you're decreasing the surface area. Right? And normally, if you're decreasing the surface area, you're decreasing the surface area for heat transfer as well. So, in a way, I can say that Q convection is proportional to surface area as well. Understood this concept? Everyone, please tell me. Yes or no? Got it? That means, in a combined way, I can say that bacha, this Q convection is proportional to AS times delta T, temperature difference. Yes or no? Okay. Okay. Newton also visualized this. Newton also observed this. When your heat transfer will go live in Guild Academy app Hindi. I mean, it will go very soon enough, but I don't know the month. Most probably next month. Okay? Most probably next month. Yeah, like FinCase. Understood, everybody? Newton too observed this. Newton too observed this. Newton also observed this. Not Newton part 2. I'm saying Newton also. Newton 2. T-O-O. And he said, okay, the proportionality is there. Now I want to remove this proportionality sign. Then what should I do? I should simply put a constant. And he said, देखो यार, there's a small constant I'm giving you. H is the proportionality constant. Okay, H is simply a proportionality constant, and this proportionality constant is very important, and this proportionality constant is known as heat transfer coefficient. What is it known as? Heat transfer coefficient. See how lazy was Newton. How lazy was he? He didn't even care to give it a simple name. See, this is heat transfer and coefficient. So heat transfer coefficient. So how much lazy was he? Yes or no? How much lazy? He was too damn much lazy in naming even. Getting my point? Getting my point? So heat transfer coefficient. Mind it, it is not a property. Why? I will tell you. But before that, see, note. Please note this concept. This is very important. Whenever I am saying delta T means high temperature minus low temperature. And whenever I am saying dt means final temperature minus initial temperature. Delta T is higher minus lower. It is always positive. Always positive. And this is always negative. Why? Because heat is transferred from high temperature to low temperature. Understood, everyone? The transfer of heat is from high temperature to low temperature. So if the transfer of heat is from higher temperature to lower temperature, that is why final temperature will be less, initial temperature will be more. Hence final minus initial dt is always negative. Tomorrow we will study Fourier's law of conduction. In that we will use dt, not delta t. So whenever we are using dt, it is going to be negative. But when we are using delta t, which is higher minus lower, it doesn't care about the direction. We are just simply saying that okay, heat is being transferred. We know that it is being transferred from higher temperature to low temperature. So we know that, hence we are using delta t. Okay? Understood everyone? So over here there is no, concern about negative sign or something. Anyways, let's talk about the unit. And meanwhile, I'll also tell you why it is not a property. Let me put as asterisk. I'll use it over there. So units, let us talk about the units. H can be written as Q over AS times delta T, which means watts per meter squared Kelvin. Yes or no? Watts per meter squared Kelvin, or it can be watt per meter square degree Celsius. Why? Because we have delta T. You can keep it in degree Celsius, you can keep it in Kelvin, it doesn't matter, because it is temperature difference here. See, in radiation we had absolute temperature, exact value of temperature. We cannot keep it in degree Celsius, but here you can, because you have difference. Okay, so it doesn't matter. Since you have difference, it doesn't matter. Understood everyone? Please take the screenshot. Please take the screenshot. Have you taken the screenshot, guys? Everybody? Okay, let me move forward. Now, also you can define it for a unit surface area and unity temperature difference. You have you have H barabar Q convection. So H equals to Q convection. H equals to what? Q convection. So what does this mean? What does this mean? Yeah, it is same for both. So what does it mean? It simply means that amount of convection heat transfer rate, sometimes definition can be asked, due to unit temperature difference from a unity surface area. Simple. Yes or no? Now please pay attention. Why is it not a property? Okay. See, I have the same surface. I have the same surface area, same geometry, everything. In this case, I have water. In this case, I have air. Okay, same everything. H changes. H is not same. H changes. Okay, now if you change the surface, if you keep this as water, this is also water. Okay, H changes. And so on. Even if you change the velocity, H will change. So H depends on various parameters. What are those? Like surface roughness, okay, velocity, density, type of fluid, length of surface, temperature, etc. In total, there are 9 parameters. Therefore, can't be a property. Thus, convection is an empirical study. Let me establish this fact here only. Many a times, while studying convection, you guys might have come across many, empirical formulae. Why? See, Newton to bol gaya bhaiya. It was Newton who said that, okay, take this small h, find this value, you'll be able to find out convection. And that's true even. But this small h is a big headache. Why? Because it changes with fluid. So if you calculate the values of h for a specific combination, let us say between aluminium surface and, for aluminium surface you are calculating, there will be a different set of values. If you change the surface, copper, the values will be different. Now if you change water from air to water, now if you are changing the fluid, the values will change. If you change the surface, values will change. Change the surface roughness, the values will change. If you change the density, the values will change. You getting it or not? You getting it or not? और किसी को टफ लग रहा है क्या? और किसी को दिक्कत हो रही है? Anybody else is facing the problem or not understanding the concepts? 2 मिनट में यार परेशान होने लग जाते हो. Anybody else? Please don't disturb me like this. I am in a separate zone altogether. And when I read these, please understand, try and understand what I am teaching you. So what happens over here is, this value of h is very, 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 I should say volatile in a sense. Why is it so? The reason for it being volatile is it depends upon various factors. So it cannot be a property. It is a circumstantial value. It is a property. Got it? It is a circumstantial value. It is never a property. Got it, everyone? That's a circumstantial value. It's not a property. So people spend their lives, just for calculating them. And hence there are empirical formulae developed for them. But we'll study those empirical formulae in a way that you will be able to retain it for a longer duration of time. Okay? Okay, everybody? If you are studying now, study with full concentration. Why? Because if you don't, it'll be a nightmare for you. Please take the screenshot. Please take it. So these are the 2 laws governing heat transfer. In short, let me tell you the summary or short notes up to as to what we have studied. See, conduction, solids, liquids, or I should say fluids, because fluids contain both liquids and gases, right? This is due to lattice vibrations plus free electron movement. Yes or no? This one is molecular collisions. Since yesterday, whatever we have studied, I'm just giving you the short notes. I've told you that this time I'll teach you in a different mode. Number 2, convection. What is it? It is simply conduction plus advection. Conduction we know. What is advection? Bulk motion of fluid particles. Okay, yes or no? It is of two types, forced and free. Number 3, radiation. Radiation, absence of any medium, there is no requirement of any medium, yes or no, and as well as due to transfer of electromagnetic waves, yes or no, simple. Number 4, Stephen-Boltzmann law. Stephen-Boltzmann law for radiation. This is for what? Radiation. What does it say? EB equals sigma T to the power 4. T is always in Kelvin. This is Stephen-Boltzmann constant. SB constant, value 5.67 10 to the power minus 8. Minus 8 it is. Watts per meter square, Kelvin to the power 4 is always in Kelvin. This is EB, watt per meter square. That is radiation flux. Understood, everybody? Number 5. What was there? Newton's law of cooling. Newton's law of cooling. Q convection equals to H AS delta T. What is it? Heat transfer coefficient, yes or no? Heat transfer coefficient. Its unit is watts per meter square Kelvin or degree Celsius, whatever you keep, right? It is not a property and depends on several factors. Got it, everybody? So up till now we have studied this. Yes or no? कोई एक अप्रोच फॉलो नहीं करेगा ना, कन्वेक्शन एम्पिरिकल अप्रोच पर एक फिनोमेनन दूसरे से अलग हो जाएगी ना, हाँ नहीं करेगा, बट आई विल एस्टैब्लिश वन pathway for you to make it easily understand. See, देख लेना, साथ के साथ में शॉर्ट नोट्स बनते जाएंगे यार आप लोगों के, है ना? You'll be having your short notes all together. So up till now what we have studied, is it clear? So from tomorrow real conduction will start, and thermal conductivity and everything I'll explain in a much depth, much detail. Sir, can we say H is a property of the system, medium HT surface under study? No, you cannot say it as a property. Actually it is not a property of the fluid, or yeah, you can say that if we combine the fluid and the surface, then we can say that yes, it is a property. But even by the definition of property, it is not going to satisfy the definition. Why? Because these are all circumstantial. So for a circumstance, for a particular circumstance, it can be, it's just a empirical value which you are obtaining, not a property. Got it? Because it is changing from circumstance to circumstance. Even if you change this surface roughness by a small amount, H will change. You getting my point? So that's why H is very volatile, I told you, right? Clear, everyone? So this is pretty much it about it. I hope you all understood. Constant and coefficient, are they all the same? No, constant and coefficient, see, whenever I am saying coefficient I am putting in order to remove this, proportionality sign. Okay, proportionality sign. And whenever I am saying constant, this constant is something which I have given by the empirical definition. I have calculated it by some rules, by some laws, by using some mathematical formulations. Getting my point? I have not put it arbitrarily. I cannot put it arbitrarily. Constant, I have to define some value. But proportionality, this coefficient, I don't have to put some value to it. Okay? It can be a symbol only. Got it, everybody? Is it clear? Everyone? Concept is clear. I hope you all enjoyed it, because I did. And even when I have trouble speaking, I took it this far. So please study it on your own, and I'll provide the notes over here on this Telegram channel of mine. Those of you who are new, please share them amongst all your peers. I'll be completing heat transfer in a record time. Don't worry about it. Okay? Machine जैसी वीडियो रेडिएशन में भी बनाए कोई एक हाइब्रिड. Okay, I will definitely. I don't know why it is showing 3 likes. For me, it is showing 45 likes. I don't know why it is showing you 3 likes. It is showing me 45 likes. No problem. ठीक है, चलो. Love you all. See you guys tomorrow. Do share it, and do share it to everyone. It is my humble request. If more and more people are coming, I am getting motivated, and I am getting much more motivation to give something extra to you guys. Okay, that is my motivation. Thank you so very much. Bye bye. Love you all. Do take good care of yourselves. See you guys tomorrow at 2 p.m. Okay, tomorrow at 2 p.m. Homework will be provided from tomorrow. Today's homework is only to revise what we have studied yesterday and today. Okay, because mathematics will be developed from tomorrow only. Mathematics will be developed from tomorrow only. है ना? That's why I'll be giving you homeworks from tomorrow. No PYQs. Up till now, no PYQs. Yeah. Tomorrow I'll give you a bulk homework. Okay? Please revise what you studied today. Okay? Just wait for the 3rd day. From 3rd day onwards, you will get the homework. Have faith. Okay? Have faith in me. Please have faith in me. Please have faith in me. Please trust me. I will provide the notes as well. Okay? On my Telegram channel. ठीक है? चलो. Take care. I will, Rishabh. Give me some time to recover and all. Thank you. Okay, Vishal. Everybody. Bye-bye. Love you all. See you guys tomorrow. Keep sharing, keep loving, and keep taking care of yourselves. Because I always treat you as my brother.